પાઈનો પ્લાન છે ને એમાંય તે 100 જણનું લાઈવ થાય છે આના જેવું ઝૂમ જેવું ત્યાંથી આવી ગયા બધા ચીકાવ પેન્ટી તમને ચીકાવ પેન્ટી એમ કહું ચીકો ઘણી હતી જરાક હમણાં 3 દિવસથી દુખાવો નથી ગોઠણમાં એકેય વાર દેખ્યું નથી કસરત કરી છે ઓલું એક ટ્યુશન બંધ થઈ ગયું છે ને હમણાં પપ્પા બેસીને કરું છું પેલા કરતા ઓછું ઉભું રહેવાનું થયું મને તો એવું લાગે છે એનાથી પેટ પડવા દાદરા ઉપર કેટલી હશે દાદરો એવો જ છે તમે ઉપર હતા એટલે આવ્યો જ નથી એટલે એમ 1-2 વાર જ આવ્યો છું 3-4 દિવસ એ બને Good evening, everyone. Yes, good evening, everyone. Those who have just joined. Okay, so let's start now. Well, the last time we derived this relation, okay, and it took quite long, right? I tried to simplify it, but if you do it with this method of comparing current, well, I couldn't simplify it, I have to admit, right? There's however you do it, the calculation does remain fairly complicated, right? So what I did was I checked it in the book. In the textbook, they have really done it in a very nice way. I really liked it. Right? You don't find me praising the textbook very often, but for this particular derivation, they have really done very well. Right? Very short, very easy. Right? So let's just discuss how it is done, or how it has been done in the book, right? Both series and parallel. All right, so let's start. Okay, so for cells either in series or in parallel, in the textbook they are comparing terminal voltage, right? They're comparing terminal voltage. We were comparing current, right? I hope you remember we were comparing the current in this situation and for equivalent, right? But by comparing terminal voltage also it's possible, and frankly it becomes very easy, right? As you can see, or as you might have seen it from the book. So let's start with that very quickly. Okay, so here suppose this is one cell, and let's say this is another cell, right? And let's say they are in helping condition. Okay, that is both are in same direction, right? Like this. So what they have done is, you don't even need to take that capital R. Okay, you don't even need to take that external resistance. Without that only you could do it very easily. It's just that you just have to take 3 points here, for example A, B and C, right? So for battery 1 or for cell 1, right, of course current will be flowing like this, right? I hope you understand why. Because the battery's positives are on that left side. Okay, so for battery 1, V1 means terminal voltage should be equal to this, and for battery 2, V2 should be equal to epsilon 2 minus IR2. Okay, and see, V1 can be easily written as potential difference between A and B, and similarly V2 can be easily written as potential difference between B and C, right? Okay, so now if you want to replace all of this by only one battery between point A and C, okay, let's say there is only one battery, and that battery is going to be epsilon equivalent and R equivalent, right? Okay, then the current should be same, all right, and terminal voltage should also be same, right? So what I mean to say is, for equivalent cell or battery, જે લખ્યો હોય બરાબર લખજો. For equivalent cell or battery, you could write VAC is equal to epsilon equivalent minus I into R equivalent, right? But clearly based on this diagram, I don't think anyone has any problem with this, that VAC is actually equal to VAB plus VBC, right? I'm sure all of you understand that. So if we use that here, so you could write therefore VAB plus VBC should be equal to epsilon equivalent minus IR equivalent. And now we can immediately put these two values, right? Last step no calculation નથી કરી દેતો આમાં series માં એમે કઈ અઘરું નથી calculation, right? You just have to put this and this here, and you will get it by comparison. આવું કંઈક આવી જશે, epsilon 1 plus epsilon 2 minus I into R1 plus R2 is equal to this. પછી આને compare કરી નાખવાનું. I hope you understood that, right? સિરીઝમાં તો બહુ ફરક નથી, આપણે કર્યું હતું એ નાનું જ હતું, આ easy છે, એમાં કંઈ નથી. But the big difference is in parallel, right? Okay, so I'm going over to parallel now, right? Okay, so for parallel, so again if you draw a diagram where two cells, આ વખતે થોડું મોટું ડ્રો કરું. Okay, maybe like this, right? So these two cells are in parallel, right? So let's say this is epsilon 1 r1, and let's say this is epsilon 2 r2. Okay, so that's what we know, right, about these two. So as usual, current will be different, right? એક અહીંયા i1 આવો જોઈએ, એક અહીંયા i2. ઊંધું થઈ જાય તો કઈ કન્ફ્યુઝ નથી થઈ ગયા ને? ગઈકાલે મેં ડ્રો કર્યું તો એમાં આમ હતું, આજે આમ છે, નસીબ. Okay, so and of course current here will become I, right? Obviously I should be equal to I1 plus I2. એટલે એ તો બધું લખવું જ પડે. Please don't ignore all that. You'll have to write that two cells are connected in parallel, okay, as shown in figure. Current flowing through them I1 I2, and total current I is equal to I1 plus I2. Okay, એટલું તો કોમન છે. ખાલી કમ્પેર કરવાનું હતું ને, એ કરંટના બદલે વોલ્ટેજ કરવાના, બરાબર? તો વોલ્ટેજ માટે પહેલા છે ને ટર્મિનલ વોલ્ટેજ ફોર સેલ 1 કે ફોર બેટરી 1 જે લખો, રાઈટ? ઓકે, એની ઉપરથી છે ને i1 ની વેલ્યુ ફાઇન્ડ કરવાની. સિમ્પલ કેલ્ક્યુલેશન છે, એક સ્ટેપમાં કરી નાખું છું, બરાબર ને? ચેક કરી લો, સમજાઈ ગયું? Is this clear everyone? Okay, waiting room માં છે કોઈ? Right, fine. Similarly, now see, this is the interesting thing here. Similarly, for cell 2, I2 will be equal to epsilon 2 minus V upon R2. બેમાં V same હશે. I hope you realize why. Can you tell me why is this V same? Can you tell me why? Can you tell me why? Very good. In parallel, the voltage will be same between this point and this point, whether you take cell 1 or cell 2, right? બસ એનાથી એટલે એવી રીતે કહ્યું. So now if we take this value, if we take this value and we put it in this value, right? Okay, પણ એના પહેલા છે ને એકવાર ઇક્વિવેલન્ટ નું કરી નાખીએ, right? So for અચ્છા અહીંયા સાઈડમાં ડ્રો કરી નાખું એટલે આપણને બે સાથે દેખાય. Now equivalent, okay? So now this is just one battery between point maybe A and C, right? Instead of two, it's just one battery, right? So હવે શું કરવાનું? એના માટે terminal voltage same જ આવજો, right? Because in parallel the terminal voltage should be same. So for equivalent cell or battery, V is again same, and it's going to be this. Clear? Because the total current is I hope you understand that, because the total current is I. So for this battery you can say that total current I is flowing. જેમ અહીંયા A થી I current બહાર નીકળે એવી રીતે અહીંયા A થી I current બહાર આવશે. I hope that is clear, right? Okay, so just like we did it for I1 and I2, based on this we can also write I is equal to epsilon equivalent minus V and the whole divided by R equivalent. Clear? Okay, આ ઉપરના જેવું છે. Now put everything in I is equal to I1 plus I2. તરત જ આવી જશે, બસ હવે કઈ જાજુ બાકી નથી. So instead of I'm going to split this and write it, કારણ કે એવી રીતે easy પડે. સમજાઈ ગયો સ્ટેપ? I'm going to split this and write it. Okay, where are these values? This is whole I1, this is whole I2, right? So now you combine terms like this and that's it. પતી ગયું જો આ બે ને સાથે લઈ લો, અહીંયા v common, minus v common. See, so easy. In fact, when I saw it, I was so happy, right? I was really pleased that they have done it in such a nice manner, and I did it in a very long way, right? And quite a tough one actually compared to this. Okay, so બસ હવે compare કરી નાખો, પૂરું થઈ ગયું. So comparing terms, epsilon equivalent by R equivalent is equal to epsilon 1 by R1 plus epsilon 2 by R2. And જો અહીંયા જોજો આ v છે, v છે. Okay, so this is 1 upon R equivalent on this side here. This is 1 upon R equivalent is equal to 1 upon R1 plus 1 upon R2. That's it. Thank you. Okay, can you hear me? All right, so I hope everyone understood this very easily, right? Right, this is actually very simple, right? And I'm sure all of you would have found this much easier, right? So that's it. હવે આનાથી આગળ એક સ્ટેપ તમે કરી શકો. Listen to this carefully. You could go one more step, and that is taking LCM here. એવું કદાચ બુકમાં કર્યું છે, મને યાદ નથી. મેં તો ખાલી એક બે સ્ટેપ જોયા તો મને લાગ્યું કે હા બરાબર, આ સરસ છે. પછી કદાચ આવું કર્યું હશે એ લોકોએ, રાઈટ? પુટિંગ વેલ્યુઝ, પછી આ કટ કરી નાખો અને આને આમ જવા દો એટલે ઓલું રિલેશન આવી જાય. બટ યસ, આઈ પ્રિફર ધીસ because it is easy to remember. આના જેવું જ છે, ખાલી શું ફરક? એપ્સિલોન લખતા જવાનું, right? So that's it about this topic, right? Okay, now the important points that I sent you yesterday, do you have any doubt with any of this? A parallel માં ખાસ આ C point સમજાઈ ગયો? I've also tried to give you an example here. Is the point C clear? I'm concerned about whether you have understood the point C. Is the point C clear, everyone? Okay, fine. Right. Okay. Well then, let's go and solve some questions based on this. Let me just check my list. Question number would be, okay, Kirchhoff rule done. This is done. Yes, right. Yeah, I recall it now. I gave you some homework questions about Kirchhoff laws or Kirchhoff rules, and I said we will solve your doubts if you have any, right? Does anyone have doubt? Okay, Jia, right? Does anyone have doubt? Very good, Kea. Okay. Right. Well done. આ બધા 100 માંથી 100 લાવશે હો આ વખતે, એવું લાગે છે. જોરદાર સમ્સ કરી નાખ્યા લાગે છે. I just hope that everybody would be doing it honestly. કારણ કે હવે કઈ સ્કૂલની જેમ હું તો તમને જોઈ નથી શકતો કે તમે શું કરો છો, તમે જાતે કર્યું કે પાછળથી જોયું, રાઈટ? સો રિમેમ્બર, you are your own supervisor, right? So please make sure you do everything honestly, right? અને જે લોકોને નો આવડ્યું હોય તો ડાઉટ પૂછી લેવાના, પછી ખાલી હાય હા નહીં કરતા. Okay, so now there has been a request about exercise question 3.9. Okay, there has been a request about exercise question 3.9, so that is what we are going to do, right? Okay, exercise question 3.9. question જોતા થાઓ, સર્કિટ ડ્રો કરી નાખો જો બાકી હોય તો. Okay, I just want to confirm whether the diagram in your book matches with mine. Is it exactly the same diagram, or is there any kind of change? Okay, right. So now about current. So first of all, generally the current that goes through the battery, we take it as I generally. Okay, rule નથી પણ એવું કરાય, right? So this is I. So we don't know what is I, so it is one unknown. Then when I comes here, you have to split it. So let's say this is I1. Okay, right? Let's say this is I1. Okay, then listen to this carefully. If you write this as I2 and say I1 is unknown and I2 is unknown, that will not do, right? Because there is a relation between these three, and that is I is equal to I1 plus I2, right? એટલે એને I2 નહીં લખીએ, અહીંયા I1 I2 લખો તો અહીંયા I નહીં લખવાનું. I hope that is clear. Okay, so let's say this is going to be I minus I1 by using Kirchhoff rule. Okay, the first rule. Now that current I1 goes here. અહીંયા તો પાછું I જ આવે. I hope you realize why. Okay, now you see here there is a symmetry in one way, right? બહુ ધ્યાન રાખવું પડે સિમેટ્રીમાં, બહુ હવામાં ન ઉડતા. ક્વેશ્ચન બદલાઈ જશે તો સિમેટ્રી દેખાશે પણ હોય નહીં એવું થાય. You have to be very very careful, right? Here because we have symmetry, A to B, look at A to B, that A to B actually would behave, listen to this, would behave identical to this C to અહીંયા કંઈક હોવું જોઈએ D, right? C to D, if you would reverse this battery. I repeat, જેવી આ સર્કિટ લેફ્ટ સાઈડ થી છે, ઓકે, એવી જ આ સર્કિટ રાઈટ સાઈડે છે. Okay, the only difference being for you to appreciate or for you to understand symmetry, હજી ચાલુ જ છે. રિપીટ ક્યાં કરવું વિશ્વ, હજી પૂરું ક્યાં થયું છે? I'm saying that whatever is AB, the same is going to be CD. I repeat, whatever is AB, the same is going to be CD if you reverse this. Okay, so what that means is, what that means is whatever current flows here like this, okay, it splits from I, the same current will come here to combine and become I, right? So that's why this is I, so this is going to be I1, and just like AB is going to behave just like CD if you reverse it, similarly AD will behave just like BC if you reverse this. And that is why if the current here is I minus I1, then the current here also is I minus I1. Okay, એટલે આવી રીતે symmetry થાય, right? Remember, we have used a lot of intuition, right? This is a challenge for everyone. Okay, come on, part of your homework challenge, right? Can you prove that current in AD and current in BC is actually equal? આ ઘરે કરજો જાતે જાતે. Can you prove that current in AD and current in BC is actually equal? ગમે તે રીતે આવી રીતે અઝ્યુમ કરીને કિર્ચોફ રૂલ્સ થી પ્રૂવ થાય એ હું તમને કહી દઉં, રાઈટ? ઓકે, સિમેટ્રી થી ન કરવું હોય તો અવિનાશ ત્રણ કરંટ લેવા પડે. લિસન ટુ ધીસ. સપોઝ યુ ડોન્ટ વોન્ટ ટુ ડુ ઇટ બાય સિમેટ્રી, સપોઝ યુ ડોન્ટ વોન્ટ ટુ ડુ ઇટ બાય સિમેટ્રી, તો કાંઈ નહીં, વધારે મહેનત પડશે, યાદ રાખજો. તો કેવું થાય ખબર છે, અહીંયા I1 આવ્યું, હવે આ પોઈન્ટ પર બે બે બાજુ જાય છે, સો યુ હેવ ટુ અઝ્યુમ સમથિંગ. તો અહીંયા તમારે કમ્પલસરી લેવું પડશે I2, right? If you take it I2 over there, then you are going to get I1 minus I2 here. Okay, then I1 minus I2 will come here, and this is I minus I1. So what will go over here will be I minus I2. એટલે અહીંયા I minus I2 જાય અને અહીંયાથી I2 આવ્યું. So I minus I2 together makes it I. So આવી રીતે થાય. So then you will have three unknowns. If you do it without symmetry, everyone, if you do it without symmetry, you have three unknowns, right? Okay, Chaitya, absolutely wrong. So if you do it without symmetry, this is what you'll have to do. But exploiting symmetry really helps here. Symmetry થી જ કરાય, બરાબર? સિમેટ્રી સમજાય તો સિમેટ્રી થી જ કરાય. અહીંયા I1, અહીંયા I1, I minus I1. ઓકે, કરંટ પાસ નહીં થાય કોણે કીધું? હે, totally wrong. So if you write I1 and I minus I1 here, right? થશે 5 બધા રેઝિસ્ટરમાં કરંટ ફ્લો થશે. So if it is I minus I1 here and I1 is going over here, right? So if you want to find how much is this, okay, use the symmetry. How much is this, right? So કેવી રીતે કરાય? Look at this. This is unknown. From here I minus I1 is coming, and over here I1 is going, right? So incoming should be equal to outgoing. So I minus I1 plus unknown is equal to I1. So that's why this unknown is going to be 2I1 minus I. So અહીંયા લખવા 2I1 minus I. Okay, so that's what we have, right? બસ current distribution પૂરું થઈ ગયું if you are using symmetry. Is this clear? Is this clear, everyone? અહીંયા શું આવશે? I minus I1 due to symmetry. Okay. Again, I would request all of you to try this and prove it. Barabar? Okay. Now let's use Kirchhoff's loop rule. પહેલા સીધું લખ નાખવાનું. Current distribution is as shown in figure. તમારે નવો ડાયાગ્રામ ડ્રો કરવો પડ્યો. ક્વેશ્ચન પેપર થોડું ફાડીને લગાડશો એક્ઝામમાં. Right. Now, so we will use loop rule. Okay, so first time એક છે ને આને x કહી દો ને આને y. Okay, so first time we'll do it for a b c y x a. Okay, so for loop a b c y x a. Okay, a b c y x a. તો શું થાય? 5 minus 5 into I minus I1. Okay, minus 10 I1. Okay, પછી plus 10, all right, અને minus 10I is equal to 0. આવી ગયા ઘરે. I hope you understood this one, right? Okay, so now let's take another loop. This time we'll take a smaller loop. Okay, this time we'll take a smaller loop. A B D A. Okay, now we will take loop A B D A. Right. Okay, so for loop A B D A, minus 10 I1 પછી શું છે minus 5 into 2I1 minus I, and then plus 5 into I minus I1 is equal to 0. મેં તમને પહેલા જ કીધું હતું કે કિર્ચોફ લો નો ક્વેશ્ચન, આ એક એડવાઇસ મેં લાસ્ટ યરે આપી હતી, લોકો માનતા નહોતા, તમે માનજો. If there is any question of Kirchhoff's law in exam, leave 3 pages and do it at last. Okay, please remember this. Now we have got these equations. હવે આને થોડું સિમ્પ્લિફાઈ કરવા માટે મને જગ્યા જોઈએ છે. So this is the advantage of computer. So now clear? This is one equation. બધેથી 5 કટ કરી નાખો. Now second. All right. Okay, so you can, I'm sure you all realize that this is a fairly simple equation compared to what you would have got, right? So now you put I is equal to 5 by 2 I1. You put I is equal to 5 by 2 I1 in 1. Okay, so putting value in 1, તો શું છે 3I છે ને, એટલે 15 I1 by 2 plus I1 is equal to 2. આવું આવ્યું. Okay, I'm going to do it here. So કેટલું થાય 17. એવા ભયાનક આન્સર આવશે ને આમાં. 4 by 17 કેટલું થશે? What do we have to find? Do Do we have to find current in everything? Okay. So I1 is 4 by 17. સાચું છે આ 0.2 હા બરાબર શું 4.25 ઓકે અરે મેં તો કેલ્ક્યુલેટરમાં જ કર્યું છે so this is 0.5875 ampere that is I બરાબર હવે શું કરવાનું હવે બધી જગ્યાએ એટલે હવે બધી જગ્યાએ વેલ્યુઝ મૂકવાની છે ઓકે so let's start check answers are they given in fraction everyone are answers given in fractions તો આપણે એ લખીએ okay fraction fine then leave it there's no need to worry about this or worry about this right so into 4 by 17 so 10 by 17 ampere okay right હવે શું કરવાનું હવે બીજી જગ્યાએ બધે ફાઇન્ડ કરવાનું અહીંયા હું ફરીવાર ડ્રો કર્યું વારે ઘડીએ કોણ ઉપર જો હોય ઓકે so this is AB બરાબર ને તો AB નો આન્સર આવી ગયો 4 by 17 ampere right now BC BC's answer is I minus I1 so I minus I1 is 6 by 17 ampere right okay and BC and AD's answer will also be same right and AB and CD's answer or DC's answer is going to be same okay now BD right BD 2I1 minus I so 2I1 minus I is equal to 2I1 means 8 by 17 minus I 10 by 17 so that is minus 2 by 17 ampere again this minus 2 by 17 ampere means in opposite direction એટલે ખરેખર આમ ઉપર જશે આમ જશે okay how much 2 by 17 ampere check કર લો answer આ થઈ ગયો બીડી માં કરંટ ફ્લો આવે તો છે ચૈત્ય શું હાવ આમાં બીજું હું તને શું હાવ નું સમજાવું મેં આખો સમ કર્યો તારી સામે હવે તમે ટ્યુશનમાં શીખી ગયા છો પણ આ વિટસ્ટોન બ્રિજ છે બેલેન્સ્ડ નથી બાકી બધા ઇગ્નોર કરજો આને હમણાં પછી આ ટોપિક આવશે ત્યારે સમજાઈ જશે બરાબર એ ક્યારનો કીધે રાખે છે માનતો નથી ક્યારનો હું ના પાડું છું તો this Wheatstone bridge is not balanced okay so this is how you can do it by symmetry I'm sure all of you would have understood that you get very simple equations compared to taking 3 બીડી માં તને શું ન સમજાણો એ મને નથી ખબર પડતી હજી કરંટ કેવી રીતે આવ્યો એમ? બાય કિર્ચોફ જંક્શન રૂલ. અહીંયા આ પોઈન્ટ પર જંક્શન રૂલ કરો એટલે આવી જશે. This was unknown. These two are known by symmetry. Right? તો પછી થઈ જાય ને, એક ખબર પડી જશે. Okay. Fine. Now, so I think that's enough discussion for this question. અને આ તમારું હોમવર્ક છે, પ્રૂવ કરવાનું છે. મને મોકલજો સોલ્યુશન લખીને. Okay. Yeah, let's go to next question that we are going to do now. Okay, so the next question according to my list is here. Exercise question 15. Exercise question 15. 1-5. હા એમ જ થાય ખોડલ, વોલ્ટેજ લો થી જ કરવાનું, પણ મહેનત કરવી પડશે. આ લગભગ એટલું સ્ટ્રેટ ફોરવર્ડ નથી, 4-5 સ્ટેપ તો થશે જ થશે. ઓકે, 15th question. Right, so 6 lead acid type of secondary cells, each of 2 volt EMF. Secondary cells શું હોય એનાથી કઈ મતલબ નથી, just keep reading. 6 lead acid type of secondary cells, each of EMF 2 volt and internal resistance 0.015 ohm are joined in series to provide a supply, and not as to provide a supply to a resistance of 8.5 ohm. Stop over there, draw a circuit before you go. I'm giving you 30 seconds everyone, after that I'm going to draw it. Draw the circuit. Tell me when you're done. Okay. Like this, there are 6. Okay, I'm just too lazy. With epsilon 2 volt and internal resistance 0.015 ohm. Okay, and all the 6 are connected in series, and then they are giving current. They are to provide, to supply to a resistance of 8.5 ohm. I hope you understood this, right? અહીંયા બહુ બધા આવશે ને એક્ઝામમાં, તમારે ડ્રો કરવા પડશે. Okay, now we have to find what's the current drawn from supply and what is terminal voltage. Current drawn, what is the formula of current when there is a battery with EMF and internal resistance? I'm waiting for you. What's the formula? Yes, Krupa, correct. So here we have to be slightly careful. We will have to write it like this because there are multiple cells, right? 6 છે ને? Okay, yes. Plus R આવે શિવાંગી. Okay, અહીંયા R equivalent લખો તોય ચાલશે હો. Don't worry about that. So finally, what's going to be the answer? What's numerator? Come on, tell me what will be the numerator. What will be the numerator? What will be the numerator? Very good, Devan. Yes. યસ 12 upon તો બહુ easy છે. What should I write here? What will be internal resistance? What will be internal resistance? Hmm. 0.09, right? The formula, everyone, I hope you realize that in series. Okay. ચલો તો થઈ ગયું ને. So this is going to be 12 upon what? 8.59. આવા કેવા નંબર આપતા હશે? કરો કેલ્ક્યુલેટર પર. 1.39 ampere. Okay. Yeah, fine. 1.4 or 1.3. Whatever. So now terminal voltage. Easy. Which formula for terminal voltage? Terminal voltage of each cell. Question માં એવું પૂછ્યું છે. Each cell. એ V equal to IR. નો આવે રમ્યો. આ રેઝિસ્ટર થોડું છે. Yes, it will be epsilon minus IR. Right? It will be epsilon minus IR. Okay. So 2 minus એકનું રેઝિસ્ટન્સ લેવાનું ઓફ ઈચ સેલ કીધું છે. હા, એપ્રોક્સ 2 નહીં ચાલે. ગેટ ઇટ એક્ઝેક્ટ. ના આમ તો સોરી, I should have read the question carefully. Just a minute. અહીંયા લખ્યું છે કરંટ ડ્રોન ફ્રોમ સપ્લાય, બરાબર. પછી અહીંયા લખ્યું છે ઇટ્સ ટર્મિનલ વોલ્ટેજ મીન્સ ઓફ ધ હોલ થિંગ. ઓકે, આઈ એમ સોરી. વી હેવ ટુ ફાઇન્ડ ઇટ ફોર ધ હોલ થિંગ, રાઈટ? એટલે આમ નહીં આવે. ઇનફેક્ટ કરવું હોય ને તો આને ઇન્ટુ 6 કરો ને એટલે આન્સર આવશે, રાઈટ? આઈ હોપ યુ અન્ડરસ્ટેન્ડ વાય. પણ એવું ન કરવું હોય તો એ કંઈ વાંધો નહીં. ટર્મિનલ વોલ્ટેજ એટલે જ ક્વેશ્ચન બરાબર વાંચો છે. supply that is 6 cells, okay, battery together. All right, okay, I hope that is clear. ઇલેવન પોઈન્ટ બધાને અલગ અલગ કેમ આવે? What is epsilon equivalent? 12 minus current is 1.39 into R equivalent is 0.09. તો આ કરો, આમાં શું અલગ આન્સર આવે તમારો? ઓકે, આઈ થિંક ધેટ્સ ઇનફ, રાઈટ? અરે બુકમાં આન્સર આપ્યો જ છે પાછળ, મને નહીં પૂછો તો ચાલશે. Yeah, it's 11.87 or something like that. Volt. Okay, fine. That's enough. Now let's go to part B. A secondary cell. હવે આ conceptનો question હો, જોજો. This one. A secondary cell after long use. એટલે બહુ વધારે use કર્યો, right? So now it's a little bit old. Now it has EMF of only 1.9 volt, not 2 volt. કેમ? એની અંદર chemical reactions હવે પહેલાની જેમ નથી થતા, right? Okay, so it has EMF of 1.9 volt and a large internal resistance 380 ohm. Okay, So what maximum current can be drawn from the cell? So this question is about how much maximum current can be obtained from a cell. ચલો કોને યાદ છે એની ફોર્મ્યુલા મેં ક્યાંક તમને થિયરીમાં લખાયું હતું. મેક્સિમમ કરંટ ફ્રોમ અ સેલ. બોલો બોલો. વેરી ગુડ માનવ. વેલ ડન ઋત્વા. યસ અવિનાશ કરેક્ટ. નો કેયા. સિમ્બોલ્સ આર રોંગ. યસ દર્શી વેલ ડન. બસ આટલા લોકોને જ યાદ આવ્યું. આટલા લોકોને જ યાદ આવ્યું. ક્યાં ગયા બાકી બધા છે? અરે ઓલો ગ્રાફ યાદ કરો ઓફ વી વર્સિસ આઈ. યાદ આવ્યું ને? અહીંયા શું આવતું હતું? મેક્સિમમ કરંટ એન્ડ ધેટ કરંટ ઇઝ એપ્સિલોન અપોન આર. અરે સીધી વાત છે. આમ આવે બરાબર. ઓછામાં ઓછો ટર્મિનલ વોલ્ટેજ 0 થાય ને. ઇફ યુ પુટ ધીસ ઇઝ ઇક્વલ ટુ 0, આઈ ઇઝ ઇક્વલ ટુ એપ્સિલોન બાય આર. રાઈટ? તો થઈ ગયું ને. આઈ મેક્સ ઇક્વલ ટુ એપ્સિલોન બાય સ્મોલ આર. એપ્સિલોન 1.9 વોલ્ટ છે. આર 480 હતું. શું હતું? કર લો ફટાફટ પૂરું. હવે આમાં કંઈક ડિસ્કસ નથી કરતો. 380. right? Okay, so that's it. Bus. Could it start a vehicle? I don't think so. This is probably too small. But એવો question કોઈ પૂછવાનું નથી. Nobody is interested in whether you can remember how much current is required to start a motor. એવું કોઈ ન પૂછે. Okay, this is information, and information has nearly no value in 12th science, right? Okay, let's go to the next question in my list. Right, there's no next question, there's a new topic, right? Yeah, there's a new topic. Fine, so let's talk about that. So the name of this topic is Wheatstone Bridge. A Wheatstone માણસનું નામ હતું. Right? Wheatstone is the name of a person. Okay. Right? So now let's see what is this thing. Wow, Avinash. So idea I put there. So what is a Wheatstone Bridge? It is a special kind of arrangement like this. Okay, આની સર્કિટ છે. પ્રેક્ટિકલી કેવો હોય પછી ડ્રો કરશું. Right? Any kind of circuit having 4 resistors. Any kind of circuit having 4 resistors like this, okay, and one connection here, okay, and here you can actually put anything. Here you can actually put anything. All right, so let's say here is a resistor. Right now let's assume here there is a resistor. Okay, let's assume here there is a resistor. So suppose these are R1, R2, R3 and R4. Can you please confirm it? તમારી બુકમાં આ જ ઓર્ડરમાં આપ્યા છે કે R2 અહીંયા આપ્યું છે? I don't want to confuse anyone. મને ખબર છે એનાથી કઈ ફરક નથી પડતો. Right? But I don't want you to get confused. Where is R2 given? Can you please check it in your book? At R1's place R2 is given. Okay, fine. હશે હાલો હવે આ લોકો બહુ ખતરનાક રીતે કરે. ચલો R1 is this R3? અરે ચાલો બસ fine. Okay, and let's say this is R5 and we connect a battery like this, right? Battery with some terminal voltage V. Actually see it does not make any difference, પણ પછી તમને એમ ન થાય કે આપણે આવું રિલેશન આવે ને આમને આવું આવે તો સાચું શું? it really doesn't matter. Okay, so here let's see this. Now what have we drawn? Why is this called a bridge? Let me explain that. See, this is the point where there are two branches, correct? I'm sure you understand. This is first branch and this is second branch, right? Okay, and then there is a cross connection. Do you see this is a cross connection between the two branches? This is cross connection between two branches, yes or no? Did you understand this? So if it is like this, that there are two branches, right? There are two branches and then between the two branches there is a cross connection. Okay, then such a thing or this cross connection is what is called the bridge. Okay, this cross connection is what is called bridge and this whole circuit is called Wheatstone bridge, right? Okay, કારણ કે આમાં bridge આવે છે. So this cross connection is what is called a bridge. Clear? Okay, so that's why this whole thing has a name Wheatstone bridge. Now let's clean this diagram up. Okay, fine. So now we are going to talk about a very specific property, right? Let's say this point is A, this point is B, this point is C, and this point is D. ઓલો હમણાં ક્વેશ્ચન કર્યો એ આવો જ હતો હે ને? And let's say this is X and this is Y. Yes, it was actually a Wheatstone bridge. That question was a Wheatstone bridge only, right? That question which we solved, the 3.9, that was actually a Wheatstone bridge. પણ એ ક્વેશ્ચનમાં Wheatstone bridge ટોપિકનું કંઈ કામ નથી, રાઈટ? તમને નામ નહોતી ખબર તો એ સોલ્વ થઈ ગયો ને તમને સમજાઈ ગયો ને, રાઈટ? ઓકે, સો what do we have here? Now we are going to talk about a very specific case, right? We're going to talk about a very specific case. What's the purpose? આવું શું કામ કરવું જોઈએ? What's the purpose of this, right? આવી રીતે અરેન્જ કરવાનો શું મતલબ? The purpose is you can find unknown resistance. You can find unknown resistance using this kind of circuit, right? Okay, so that's the purpose of setting it up like this. Okay, so what you could do is you could set any one of the four to be unknown, right? Suppose there is out of these five, actually out of these five, if either 1, 2, 3 or 4, out of these four, if one is unknown, right, then you can do it very easily, right? Then you can do it very easily, right? You can find it on find that unknown. So let's say that this is unknown resistance. Okay, let's say that this is unknown resistance. ચાર માંથી ગમે તેટલો unknown તોય ચાલે, result same જ આવે. So you could write, let a Wheatstone bridge capital લખો જાય, let Wheatstone bridge be made as shown in figure. Okay, R4 is unknown resistance, right? R4 is unknown resistance. What we can do is we can actually put something called a galvanometer here, right? Okay, G is the galvanometer. Galvanometer હોય કે ન હોય એને Wheatstone bridge જ કહેવાય. Let me tell you that, right? Okay, I'll just stop here. I actually didn't notice that we are running out of time. That's why I started explaining. But anyways, let's stop here. Okay, આટલું પૂરું કરી નાખું, આ શું લખ્યું છે. So we are saying that we have made a Wheatstone bridge from these resistors, right? And R4 is the unknown resistance. Okay, and we want to find it. And we have connected a galvanometer here. G stands for a galvanometer, right? Okay, so what is a galvanometer? It is an instrument that can measure or detect current. It means it will tell us એની અંદર છે ને ઓલું જેમ સ્પીડોમીટર કેવું હોય, સ્પીડોમીટર જોયું ને, right? Like that there is a needle in a galvanometer. Like that there is a needle in galvanometer. આમ જાય ગમે તે બાજુ જાય depending on current, right? અને વચ્ચે અહીંયા 0 હોય, વચ્ચે અહીંયા છે ને 0 હોય. So that means if the needle stays at 0, then here the current is 0, right? So again, a galvanometer is an instrument that can measure or detect current, right? એટલું સમજાઈ ગયું? Is this construction or is this arrangement clear? Next time we'll see how we can find R4, right? Next time we will see how we can find R4. Okay. Right, so let's wind it up today. That's enough. Goodbye everyone. See you all tomorrow. ના સિમિલારિટી જેવું નથી આ કોડલ. ઓકે, આ ટ્રાયંગલ્સ નથી ને, એટલે એવું સિમિલારિટી જેવું ન હોય. We'll have to use Kirchhoff rules to get it done. Okay, we'll have to use Kirchhoff rules. Goodbye.